of exponential and logs, we're actually up to the logarithms now. So we're going to start off going through the log laws. Okay, they're similar to index laws. They're on your formula sheet, and they take a bit of getting used to, but the more you practice, the easier they are to use. And then in another video, we're going to take those log laws and use them to work with logarithmic functions. So this slide here is from your formula sheet. The useful log results over here you'll use all the time. The actual log laws over here spell out kind of what you can and can't do. So you can plus logs, minus them. You can move the powers around and you can divide. So, and down here, this is what a logarithmic function looks like. We're not going to do that in this video yet. We've got a bit to go before there, but it's like an exponential function, except it has that vertical asymptote instead of the horizontal one. So again, it's something that grows gradually and then really takes off. So let's look at first of all our useful log results and our definition for the first one. So here, this is just off your formula sheet, up this top part. Y equals a to the power of n is the same as log base a y equals n. Okay, it doesn't make much sense if you haven't seen it before, but what it's saying is that we can rearrange these to actually make sense. So I'll show you through an example with the first one. So what we're doing, we can see a is here, a becomes the base, so 5, n becomes the power, and y goes out by itself. Oh, it would help if I actually put it there, wouldn't it? So y is 25 in this example. Okay, so a, y, and n. So this makes it a lot easier for us to see because it's in index form now. It looks a lot more familiar to what we're used to. And it's pretty much saying 5 to the power of what equals 25. Okay, the same thing here. If you learn how to read them, it says 5 to the power of something equals 25. What is that something? Okay, so 5 to the power of x, well, we can write 25 as 5 squared. Okay, if we've got one on each side and the base is the same, we can drop it out. X is 2. Okay, so that's rearranging and writing, but if you see this, you can go 5 to the power of what equals 25. 5 to the power of what equals 25. The same here, 7 to the power of what equals 49. So we can use this log law to rewrite it, make it make a bit more sense. So my a comes out here, my y goes over the other side, and my n becomes the power. Oh, I've done it again, I'm sorry. Okay, so we need to figure out how to put these as the same bases. Obviously 7 squared. So again, x equals 2. So the reason we're doing this is so that, like if you had something like this, 7 to the power of what equals 49, the current methods that we have is really guess and check. We just keep going up our 7 times tables until we figure out, not 7 times tables, sorry, we keep like squaring it, cubing it until we get to 49, but it is trial and error. Whereas this here, we can actually put in our calculator. So I'm going to do that, log base 749 on my main screen. And let's see if I can find it. I'm used to using the calculator you guys have. So over here, you can see there it's log to the base 749 is 2. Okay, so if you're given something like this and you don't know what it is, you can use logs to rearrange it and then it can go into your calculator, or you can put it into indices and use guess and check. So just a couple of options. Let's try this last one. So we've got here, we can rearrange 2 to the power of what equals 64. So we can use our calculator on this one, or we can guess and check on this one. So 2 to the power of 1's 2, 2 squared 4, 8, 16, 32, 64. So it's 2 to the power of 6 equals 64. Therefore, a equals 6. Okay, or I can take this and pop it in my calculator, log base 2, 64. equals 6. Okay, so we can go from logs to indices and back again, depending on what suits us and depending on what will give us that answer. So now we know the basics of what we're doing with logs. We're trying to find out this to the power of a what kind of thing. We're going to have a look at our first log law. So our first log law states that when you're adding logs and they have the same base, so base A, it's log base A and you multiply M and M, M and M, M and N. So let's try that. I've got some examples here and I've just put the log up. So the first thing we're going to check is that our bases are the same. So this one is a base 2 and this one is a base 2, which means we can use this log law. Okay, you see how it's similar to index laws? These little rules that the bases have to be the same. So if the bases are the same, I can turn it into log base 2 4 times 32. Okay, and then it would be log base 2, I wish I brought my calculator, 64, okay, 128. So we've got two options where we can go from here. So we're trying to kind of say 2 to the power of what equals 128. Okay, so again, we can guess and check, or we can use our calculator to find out what log base 2 is of 128. So let's try this, log base 2, 128, putting it in the wrong spot, up there. Okay, so 2 to the power of 7 equals 128. Therefore, this log equals 7. Okay, so again, we could figure it out by going, well, 2 to the power of 1 is 2, 4, 8, 16, 32, 64, 128. Okay, we can use both. We can do it on a calculator and a non-calculator section. I've left an answer there by accident. So let's try the next one down. We're going to check that the bases are the same, which they are. We're adding, so we're using this law here. So it'd be log base 5, 25 times 5. Therefore, log base 5, 125. Okay, and then we're going to try and figure that out. So 5 to the power of 1 is 5, it goes 25, then it goes 125. So 5 to the power of 3 equals 125. Therefore, this is 3. Again on the calculator, log base 5, 125 is 3. Okay, so with all of these, we're trying to go 2 to the power of what equals 128. Okay, 5 to the power of what equals 125. Okay, so the base tells us the base here. We're trying to find the power. So let's try this last one. Check again, our base is the same. Yes, we're using plus, so we're using this rule here. So log base 10, 40 times 25. Really regretting not bringing a calculator with me. 425 is 100, plus 1 is 1,000. So log base 10, 1,000. So we're trying to find 10 to the power of what equals 1,000. Okay, so 10 to the power of 1 is 10, to the power of 2 is 100, to the power of 3 is 1,000. Therefore, this log equals 3. Okay, and I'm going to check that on the calculator too. So we've got log base 10 to the 1,000 equals 3. So if this was the calculator section, they wouldn't give you something like this because you can put the whole thing in there. So let's try checking our answers as we would in class. So log base 10, 40 plus log base 10, 25 is 3. Okay, so you can check your answers pretty easily with these ones. They take a little bit of getting used to, but you've got your formula sheet there, so make sure you use it. Okay, let's move on to the next index law. So this one is when we have, again, the same bases, but we're taking the logs away from each other. And when that happens, we're dividing m by n. So let's try it with this one. First of all, I'm checking my bases are the same. Yes, they're subtracting, so I'm using this law. So I'm going to go log base 2, 160 divided by 5, or 160 over 5, doesn't matter which way you write it. Therefore, log base 2, 32. Yeah, 32 is what we've got so far. So we're trying to find out 2 to the power of what equals 32. So 2 to the power of 1 is 2, 4, 8, 16, 32. It's 2 to the power of 5. Therefore, log base 2 of 160, take log base 2 of 5 is 5. Okay, we can check that on our calculator. Log base 2 of 160, take log base 2 of 5 equals 5. That's how we check our answers using the calculator. Let's try the next one. So again, checking the bases, they're the same. We're using minus, so we're using this formula here. Log base 10, 100,000 divided by 10. Therefore, log base 10 of 10,000. Okay, so 10 to the power of what equals 10,000. That's what we're trying to find. So 10 to the power of 1 is 10, 2 is 100, 3 is 1,000, 4 is 10,000. So here, log base 10 to 10,000 is 4. I'm going to check that. Again, we're going to check the one we simplified it to first. Is 4. Okay, and the last one, I'm just looking at those numbers now. I'm very much going to cheat and use my calculator. Log base 3, 1458 divided by 6. Log base 3. All right, let's have a go at doing it manually. I probably need a bit of practice. So 1458, 6 doesn't go into 1. Goes into 14 twice with 2 left over. It goes into 25 4 times with 1 left over, and it goes into 18 3 times. So log base 3 of the 243. Okay, so 3 to the power of what equals 243. Here goes nothing. So we're starting off with 3. Squared is 9. Cubed is 27. 27 times 3, 21. 81 times 3, 243. So it's 1, 2, 3, 4, 5. So 3 to the power of 5 equals 243. Yeah, I know those little scribbles take a lot of time, the multiplying and dividing and things like that. Just take the time in class to practice them, especially fractions and things like that. It just makes it easier when you don't have a calculator on your test. So that is our second log law. Hope that makes sense. So we're just trying to find out to the power of what would it be. Probably should check that last one because I'm not overly confident at my skills there. Log base 3, 143 is 5. Okay, good. So this is our second last log law. We're nearly there. This one states that if you have m to the power of something, in this case p, you can take p out the front of the log and it will mean the same thing. Okay, so this is one where you've got to do that kind of splitting the base, finding the prime base, just like in index laws. So index laws and logs are, they're opposites of each other, kind of, they undo each other. So here we're going to have a look and we're trying to make these prime bases. Actually, no, sorry, we won't make them prime bases. We'll make them base of 8. So I can rewrite 64 as 8 squared, okay, because 8 8 is 64. And we can make this log base 5 of 8. That can stay. Okay, and then this here is p. I can bring that out the front with no consequences. So I'm going to go 2 log 5 of 8 over log base 5 of 8. Okay, you might be thinking, what's the point of that? Here's a little trick. Log base 5 on the top, there, they cancel out. And my answer in this case is just 2. Okay, so log laws are one of those, like indices, you just kind of fiddle around a bit and see where you go, and it takes a bit of time to learn to identify what's going to help and what's going to go around in circles a little bit. So let's check that with a calculator first of all. So I've got a fraction bar, and I'm going log base 5 of 64 divided by log base 5 of 8, and my answer is 2. Okay, so that's using that index law where we're bringing things out the front. Let's try it again. So I could do two things here. I could make this 5 to the power of something. I could make this 5 to the power of something. Oh no, sorry, that's my only option. I was thinking I could square 25, but 25 squared is not 125. So we're going to have to make them base 5s. So 5 squared gives me 25. And 5 to the power of 3 gives me 125. So those powers can come out the front. Okay. They're the same, they cancel out. So my answer is 2 over 3. Okay, again, like index laws, you often have a combination of different skills that you've got to use all in the same go. And let's try the last one. Actually, no, this is my last slide, don't I? So we can make them both base 3. I only know that because we looked at it before. So this would be 3 to the power of, down here, to the power of 5, cheating a little bit. And this would be 3 to the power of 3. Okay, powers come out the front. Same things cancel out. And my answer is 5 over 3. Or 1 2/3. I just normally leave it in an improper fraction. They seem to work out easier in this course. Certainly don't swap it to decimals unless it's specifically asked to. Okay, so we've gone through 1, 2, 3 of them. This last one down here, I'm not going to worry too much about because it doesn't pop up much. And if it does, you can kind of get around it using the other ones. What I do want to look at are these two simple log results down here. So let me just find, here we go. So we've got log base anything that is 1 equals 0. What that's saying is that if you have anything to the power of 0, so you have 3 to the power of 0, 5 to the power of 0, 100 to the power of 0, anything to the power of 0 is always going to be 1. So if it's log base anything to the 1, it's going to be 0 every single time. Okay? If you forget that, that's okay. You will get to the point where you go anything to the power of 0, oh, that's just 1. But if you can identify it first up, it makes it a lot quicker. Same thing here. If you go anything, base anything and the answer is anything, say like 10 to the power of what equals 10, or 50 to the power of what equals 50, or x to the power of what equals x, that is always going to be 1. Okay, so if the base is the same as this, your answer is 1. Okay, again, you will get there if you forget that. It's just a little shortcut to remember that they are there, and they are on your formula sheet. So if you see anything kind of funny, just double check your formula sheet and it should work out. So that is the end of our log laws. In the next unit, we're going to bring it all together and we're going to start graphing logs and translating and that kind of thing. So enjoy your practice. So that's our second last log law. Let's have a look at the last one.